In this lesson, I'm going to talk about how to force a string to resonate. But before that, let's talk about forced vibrations. So imagine a skipping rope which is attached to a doorknob or to a fence post. So here's a diagram. This red line represents the skipping rope and tied to a fence post. And if you take your hand and you flick the loose end of the skipping rope, you'll send a pulse down that skipping rope and it'll travel, hit the post, and it'll reflect back towards your hand. And it'll just kind of keep traveling like that until it dies out. Now, if you keep flicking it up and down, you keep forcing that skipping rope to vibrate. And the faster you flick it, the faster the skipping rope will vibrate. So it will do whatever your hand does. But it's not very spectacular. Now, a spectacular thing is making the string actually resonate. So how do you make a string resonate? Well, what you have to do is you need to match the flicking of your hand to the natural frequency of that skipping rope or string. So if the natural frequency of that skipping rope happens to be 6 hertz or 6 vibrations a second, that's the speed at which I'm going to have to vibrate my hand up and down. I have to force a very specific frequency to make that resonate. Now what's interesting, when I flick my hand up and down at a non-natural frequency, let's say I flick it up and down 10. Well, that's not the natural frequency. We said it was 6. Well, that will vibrate up and down at 10 times, but the size of the wave will be equivalent to whatever the disturbance is. So if I lift my hand up and down 6 inches, that wave traveling through the skipping rope will be 6 inches high. But if I'm at the natural frequency, my 6-inch up and down motion can actually grow. And the reason it grows is if I am in phase means that I'm matching the up and down motion of my hand with the up and down motion of the wave. That's what in phase means. So, translation. If I flick this on the first time, when the wave returns to my hand, right at that moment, that's when I make the other flick. And then it goes and comes back again, and then I make a third flick, and so on. That means I'm in phase. If I flick my hand when the pulse is on the opposite end, I will be completely out of phase, and it won't work. So I have to match not only the natural frequency, but the timing of my pulse has to be in phase with the wave in the string. Okay, so if I want to cause this to resonate, I have to move my hand up and down at the natural frequency of the string, and I also have to be in phase. And what will happen is every time I flick again, the wave will add on to the previous wave, and the overall wave in the skipping rope will grow larger and larger and larger until it can't stretch anymore. And that amplitude will be larger than my small little disturbance. And once I've accomplished that, we call that a standing wave. And a standing wave means that the wave is kind of fixed or frozen in air. So we see the top of the wave and the bottom of the wave almost at the same time because it becomes like a blurred image. And we call that a standing wave.